Welcome to chemistry class. Let us start with a new model problem based on equilibrium constant. Let us see a question. What is the value of equilibrium constant for a reaction A gives rise to B if equilibrium constant for a reaction B gives rise to A is 0.25. Okay. If the question is like this, what they ask you, what is the value of equilibrium constant for a reaction A gives rise to B if equilibrium constant for a reaction B gives rise to A is 0.25. Is it clear? Now let us solve this problem. See here, there are two equations they have given. A gives rise to B and B gives rise to A. Okay. Let B gives rise to A being the equilibrium constant of this reaction given in the problem, it is to be considered as equation 1. Is it clear? B reversible arrows A. Okay. So this is equation 1. Okay. And we have to consider the equilibrium constant as K for this reaction. K is equal to 0.25. Is it clear? Now, let us go for another equation given in the problem. A gives rise to B. So, for this we have to find equilibrium constant. Okay. So, A gives rise to B will becomes equation number 2. Okay. For this we have to find equilibrium constant. Let that as K dash. We have to find K dash. Is it clear? So, if you observe clearly, the second equation for which we have to find equilibrium constant is absolutely reverse to the first reaction. Is it clear? Second equation is absolutely reverse reaction of first equation. Okay. For such cases, the new equilibrium constant K dash will becomes K dash is equal to 1 by K. Okay, so this is the concept we have to know. Is it clear? Now let us substitute the values. You can easily find the new equilibrium constant. Okay, let us see. K dash is equal to 1 by K. As we know that K is 0.25. Then K dash is equal to 4. Okay. So this is the way to solve such type of problems. But here the student should read the question carefully and he should go through the data of the problem. Okay. Here one should identify the pattern of the reactions given. Here in first and second equations we have to observe one thing. The second equation is the reverse equation of first equation. Okay. So after knowing that, by remembering the concept, one can solve this problem easily. Okay, thank you. Now let us solve one example. Okay, so here see what I did here. Just I have replaced A gives rise to B and B gives rise to C with the particular given substances. Okay, here in this problem. Let us see what is the value of equilibrium constant for a reaction 2NH3 gives rise to N2 plus 3H2. Okay. If equilibrium constant for a reaction N2 plus 3H2 gives rise to 2NH3 is 2. Is it clear? Okay. So now let us see what will happen. Okay. So here, as usually, as we have solved in the example problem, general problem, we can also do it for this. Okay. So let us see, let us pick up the equations at first. As the value of this equation given in the problem, we have to take this problem as equation 1. Okay. Is it clear? N2 plus 3H2 gives rise to 2NH3. Okay, this is equation 1. The equilibrium constant given in the problem for this reaction is 2. Is it clear? So now let us see the second equation. Okay, for this they ask you to find equilibrium constant. So it is to be considered as second equation. Is it clear? So now 2NH3 gives rise to N2 plus 3H2. This is to be considered as equation 2. Okay. So now what we have to find? K dash we have to find. Okay. For known we have to take it equilibrium constant as K. For unknown we have to take equilibrium constant as K dash. Okay. So now also we have to go through the concept, that is for such cases, that means if there is a reversibility in the reactions, then K dash is equal to 1 by K. So as we have seen in the example problem. Okay. So now see here, K dash is equal to, we know that K is equal to 2. So we have to substitute the value of K in this equation. K dash is equal to 1 by 2. Is it clear? It is equal to 0.5. This is the answer for this problem. Okay. So just I have done an example problem for your convenience. Okay. Keep in mind and apply the same to the all problems which are similar to this. Okay. Thank you.